Hey everybody, this is Larry. This is day 2 of the February Legal Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. Happy New Year for those of you who are celebrating. And yeah, hope you have a good lead coding something. I don't know. Today's problem is find all anagrams in a string. Okay, so given two string S and P, return all the way, we return any order. What does that mean? A, B, C, O and 6. Oh, because this O3 and 6 is BAC. Okay. So, I mean, this is going to be sliding window. That's the short answer. Right? I mean, I think that's an intuitive thing to figure out sliding window. And then the second question is, how do you check in a good way, right? Because if you do it naively where you count the number of A's, count the number of B's, and the count the number of C's, and then you have to check every time whether they match. Well, that's not going to be, well, I mean, I guess it'll be linear times 26, but that's still suboptimal maybe. The way that I would do it is maybe think about it the other way, right? You start with 1A, 1B, and 1C, and then all you have to do in that case is to check whether it is equal to 0 or something like that. So that's basically the idea. It's just with a sliding window and just counting it in and out, right? So that's, yeah, okay. I think from that it's just implementation, because an anagram is, just to be clear, you just have the same number of A's and B's and C's and all that stuff in that window, and you know the length, which is of course the length of P. So yeah, so okay, let's get started. Let's set n is equal to the length of S, and M is the length of the pattern. And then here we want to start with a counter of the pattern string, right? And then now that's basically the idea. I always forget. Actually, let me check something real quick. Collections.counter. I forget whether there is a thing that tells you how many items are in there. Maybe not. I mean, it's fine if there wasn't. It's just that then we would have to do it ourselves. Dot elements, most common, subtract, total. Oh, there is one. It's called total, and it's apparently new in 3.10. So I might not have it. I don't know. Let's see. Oops. I thought I saw it, but yeah. Learning something new. Okay, so as you can see, the pattern is 3, so that has 3 items to begin with. And I would check again to see that it handles the duplicate case well. So let's see. So that should be 3 in this case. Okay, so then that actually makes it a bit easier for us, because then now we could check whether it's 0. Because if if you check whether it is 0, then unless that complexity isn't good, I don't know. But yeah, once if this thing is equal to 0, then yeah, then that means that everything matched, right? That means that the delta is 0. So this is counter. Maybe you can think about it as the difference between our thing and our pattern and our current substring. So let's get started, and we'll write our sliding windows starting from I. Okay, so now we want to subtract this from the delta. So delta sub S, we subtract 1, right? And then wait, not S, whoops, S sub I. And then of course, if I is greater than or equal, is it greater than equal? I always forget which. I have to think about it. If I is exactly M, what does that mean, right? That means that if I is exactly M, then we have M plus 1 characters. So that means that we have to remove S sub I minus M, put back to 1, and then if I is greater than this minus 1, because that means that if I is equal to M minus 1, then you have M items, right? So that's basically the reason. And then if this is the case, and delta dot total is equal to 0, and you actually don't need this but this actually turns out to be way easier. So the way that you would do it if you don't have this is that on this subtraction, if this, and this is the only case where this can happen, if this subtraction makes this a 0, you can remove the key, and then this would just check to see how many keys are in there, because 0 is an easy thing to check. Anyway, if this is the case, then okay, we want to store this index, kind of. Well, because I is the end of the index, so we just have to store the beginning. So we store I minus m. Yeah, so I minus m, I minus m minus 1. Yeah, I think I minus m. The way that I like to think about these off by ones, or like potential off by ones, is just use real number, right? If m is 2 and I is 1, well, 1 has 0 and 1, so m is 2, so that means that I should add plus 1. Okay, also of course add this as an array, and then that's pretty much it. Hopefully, let's run it. Oh, wrong answer. Huh. Now I'm just returning everything. Why is that? Dun dun dun. Am I just returning every index? No, I'm. Yeah, I am. That's awkward. Huh? Maybe the total thing isn't quite right. Let's see. Oh, because there's a -1. Huh? That makes sense actually. Okay, so this doesn't quite work. At least not intentionally as I had hoped, but and we could do a couple of other weird things, but I feel like you could check whether the keys are matching, but that's fine. We can do it without. Like I said, we can do something like if is equal to 0, we delete the key, right? And then we also do this for here, for the item that we remove. And then now we can just check whether length of delta is equal to 0, right? And that looks good, so let's give it a submit, right? Is there any other weird case? Let's see. I guess P could be longer than S, but that shouldn't really fucks my my solution. Like that just returns nothing. I meant faster. Wow, what did I say? Oops. Sorry, friends. All right, let's give it a submit. Penny did this about a year ago. Okay, cool. 673 days of streak. Yeah. So what's the complexity here? This is going to be linear time. You go through the linear things. This counter thing looks like it may be linear space, but actually, I mean, I guess it is kind of true. But this string can only have 26 characters, right? So it's going to be actually O of alpha space, where alpha is the size of the alphabet. In this case, 26 characters. So you can also say it's constant depending on who you ask. I always like to show the size of the alphabet and stuff like that. So yeah, so this is O of alpha, but otherwise everything is O of 1. So I guess technically this could be linear, so that's output sensitive. So the space is actually O of alpha plus K. Let me just type it out then. O of alpha plus K, where U is the size of, I guess I said alpha, hang on. Size of the alphabet, and K is the size of the output. And then this is just linear time. I guess N plus M, because you have to, it's linear in the size of the input, which is the size of S or the size of P, because we have to go through, this is the size of P and this is the size of N. So yeah, cool. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see you later. Have a great rest of the week, and also have a great rest of the month. We'll be doing this all month. So yeah, hopefully I'll see you back here. See you soon. Bye bye.